The friction coefficients mu and k can be determined at the field by conducting a friction test. The concept of friction test is to apply a load at one end, termed as an active end. At the same time, we measure the load at the second end, which termed as a passive end. The load measured at the second end is the load minus the friction loss and other immediate losses such as anchor set and elastic shortening of concrete. The test should be conducted for each group of tendons with a similar profile. For example, if there are tendons with a parabolic profile and tendons with a straight profile, two separate friction tests should be conducted for each group because the friction coefficients are dependent on angular change of duct. The procedure of the friction test will be as follows. Once the tendon is selected, identify the active end and passive end. The passive end for measurement of load. Then we install anchor blocks and wedges at both ends. Fix the jack at the active end and connect it with the pump. Apply an initial 20 to 40 bars at the active end so the anchor block will be flushed to the face of the bearing plate. Then release the pressure and prepare for the test. Fix the lift-off chair at the passive end. Jack will be seated at this chair. Fix the passive jack and make sure it is seated properly. Extend the jack piston for 30%. Then the load will be applied at the active end. Load increment can be 25%, 50%, 75%, and 100%. We should record the elongation for each increment. At the passive end, record the pressure and movement of the piston. The pressure recorded at the passive end is the effective pressure after friction loss. The data acquired from the friction test will be used to calculate friction coefficients. For any tendon, there are two unknowns, the coefficients of friction mu and wobble k. However, the friction test can be used to measure the amount of friction loss for a given tendon. Then friction equation can be utilized to acquire friction coefficients. Consequently, two unknowns mu and k have to be derived from one equation. This is not possible unless one of the unknowns is already known. Therefore, we can assume mu or k and calculate the other coefficient using the equation. The friction loss equation discussed in the previous lecture. In the straight portions, there is no wobble, so in such case, we can assume k equals 0. Thus, mu can be calculated easily from the friction loss equation for this special case. If the friction test cannot be conducted in the field for any reason, H2 code provides us with a table containing the value of friction coefficient for different duct materials. These values can be used to calculate the friction loss. But it is better to conduct a friction test as it is more accurate. Let's assume that a friction test conducted and the active end reading equal 365 bar and the passive end reading equal 321 bar. Assuming that alpha equal 1.4 rad, L equal 156 meter, the instantaneous losses at the active end are 2.91% and 2.33% at the passive end. The pre-stressing force at the active end minus the instantaneous loss equal B0 equal 354.38 bar. For passive end, the pre-stressing force equal 320 plus 320 times 2.33 divided by 100, which is equal 328.48 bar. We add the instantaneous losses at the passive end because we need the friction loss only. We need to assume k to calculate mu. Let's assume k equals 6.6 times 10 to the minus 8. If we rearrange the friction loss equation, we will get the following equation. Using this equation, we will get mu equal 0.046. By knowing mu and k, friction loss can be evaluated precisely for all tendons.